Hey, Algebra 2 honors. I had a few students ask questions about this one. They had questions on the homework, and a lot of people made good progress on this, but didn't quite get the full answer. So I want to explain all the parts to this. It says, let A and B represent constants. Solve each system. So let's pause there. It's a system of equations. X and Y are the variables. A and B are some unknown constants, but we think of them as fixed. So A could be 2 and B could be 7, for example. X and Y are variables. So we treat A and B like they're constants. What condition must be placed on the constants in each system to be certain that the system has a unique solution? So we need to solve it and put conditions for solvability. Definitely an honors Algebra 2 level question. So we begin by solving this, and because of the way it's presented, the natural approach would be to use elimination or the linear combination method. And I'll do that. So I told you that I don't like subtracting equations, and I don't recommend it when you're getting good at solving systems. When you're still learning, it's easy to make minus sign errors when you subtract equations, subtract one from the other, because you might end up subtracting a negative, and sometimes I see students make errors on that. So what I recommend is multiplying one of the equations by -1 and then adding everything. That will help you also down the road when you study matrices and things get a little bit more complicated. It's a good habit. X plus y equals a. So I multiplied the first equation by -1 to swap all the signs. And now I'm going to add. I'm going to add the two equations. Okay. And put that in red. If I add the two equations together, I get -ax plus bx. The sum of -y and y is 0. And I'll add these together. So I'll get a plus -b or a minus b. Now, on the left-hand side, I can factor out an x, and I'm left with b plus -a or b minus a. And I can divide both sides by b minus a. Okay, so we've solved for x. Awesome. First, we can simplify this. Second, whenever you're dividing by unknown parameters or unknown constants, you should have like an alarm that goes off in your head to say, I need to be worried that I'm dividing by 0. You got to consider the possibility of dividing by 0. So can you see right now, we would be dividing by 0 if A and B were the same value, or if they were both 0. So we can't have them both be 0, and we can't have them be the same value. Otherwise, b minus a is 0, and we don't want that. So the condition that allows you to have a solution, and indeed a unique solution, is to make sure that a does not equal b. That includes the case of them both being 0. One of them can be 0, but not both. Okay. Yep. So the condition we have is that a is not equal to 0. And now we want to solve the system assuming that condition. Okay. X equals a minus b over b minus a. But we can simplify further because we can factor a -1 out of the numerator or denominator. Let's factor it out of the denominator. If you factor a -1 out of the denominator, it becomes a minus b. Because if you factor a negative out of b, it becomes -b. If you factor a negative out of a, it becomes positive a. So I can switch the order of the subtraction. And now a minus b over a minus b is 1, so this is -1. So as long as a is not equal to b, x equals -1. To solve for y, we just got to plug -1 back into one of the equations. So we got this. We can express it with we've got x. Now let's figure out y. A times -1 plus y equals b, so y equals b plus a. Awesome. So we could write it separately like that, or we remember that we're solving a system, so a two-dimensional system, because there's two variables, x and y. So that means we're looking for a point in the plane that is simultaneously on both lines. And what we have is the x-coordinate of the point is -1, and the y-coordinate is b plus a. So this is a nice way to represent the answer with the coordinate point. You can also sometimes in different contexts write out the x and y separately. Just be clear. And our condition was that this was only solvable with a unique solution if a is not equal to b. All right, hope this helped.